Welcome back to the Sustainable Design Lab podcast with Veritiv. I'm Brodie, Vander, Dussen.
And I'm Chris Bradley.
And on this show, we bring you the innovators and the leaders who are really reshaping the future of packaging.
And today, we are bringing a very amazing guest, Pierre Paslier. He's the co-founder and co-CEO of Notpla. Notpla is a London-based material innovation company that takes seaweed and turns it into new types of packaging. I've been really impressed with this company. It's one of the real standouts in the field. I first discovered them when watching the Earthshot Prize back in 2022. They were the winner of the very first Earthshot Prize coming from the UK government. And then Brodie and I wound up meeting up with Pierre a few years back at an SPC convention and had some fun nights and time and have really developed a strong friendship over time. This is a conversation that you're not going to want to miss. So let's tune in.
It was great. Let's get into it. Pierre, can you take us back to the beginning what first sparked your interest in replacing plastic, and how did that idea evolve into what we now know as Notpla?
Yeah. So I started my career as a plastics packaging engineer. I was working for L'Oreal, the cosmetic company. So like projects that would be like hundreds of millions of cream jars and like shampoo bottles and all these things that obviously do a really good job, and the engineering that goes into it is incredible. But also once they're used, they're leaving plastic behind, and that is a material that is kind of indestructible. And so I was starting to be conflicted about how much I was like trying to continue and perpetuate that system, was excited about working on alternatives. So I quit my job, came to study a master's in London, where I met my co-founder, Rodrigo, who was an architect. So again, like coming at this from very different angles. He was using actually plastic as a waste, and turning people's eyes on it to become a resource by building pavilions with bottles and trying to show that plastic is a very valuable material. So again, like trying to reflect on like the wonderful properties of plastic and making people see that. And the project really started as a experiment in our student kitchen. We had this like weird idea: what if packaging was a fruit? How do we do biomimicry? How do we think of materials that feel like they could be the peel of a fruit that we're going to try to create? And so out of that exploration and doing little experimental dinners with our guinea pig friends, we would just cook up all sorts of weird and wonderful propositions. We stumbled upon the way fake caviar is made. If you've ever had those like fake fish eggs, the membrane in there is actually made from seaweed, from brown seaweed. And so that was like a bit like a wow moment. But if this is made from seaweed, can we use and harness this material to kind of like make those bubbles bigger and bigger, and make something that really feels like a fruit? And it was transparent, surprisingly. It was edible. So we thought, wow, edible packaging. That's kind of cool. Made a video, wrapped up the project, move on with our life. And then it turns out that this video went viral. And all of a sudden, there were like millions of views. People were talking about it as the future of packaging. And we were like, wow, it was very unrefined. It was smelling like the sea. It was terrible. There was many reasons why it wouldn't work. But seeing the excitement of people, we were like, wow, there's something to do here. Maybe we can introduce seaweed as one of the new material categories in the market, to have something that's more natural, that actually, has a chance of breaking down in nature without human intervention. And so that was the moment we were like, maybe we should do this as a real company.
Wow.
That's pretty exciting. That first bubble that you created, that kind of early prototype, what did it really teach you about consumer perception, behavior, or maybe like the realities of kind of doing this type of scaled innovation?
Yeah. I think it was like super challenging, the status quo. It was a form factor and a behavior that was completely different from plastic, which was amazing for getting a lot of attention, but also it was not a drop-in replacement at all. It was requiring a completely different material and eventually like a different manufacturing technology and a different way to think about the moments of consumption. So it was more than anything a way to challenge the brief and get ourselves a seat around the table to talk about the future of packaging. And so for that product, we found a very specific application for running events or marathons, where there's huge consumption of like water or energy gels. And so we felt, okay, this makes sense for that context, but that's not going to replace the way you buy kind of like bottled water in the supermarket. We don't have a solution for that. That's just too different. And there's always the question, like, if it's edible packaging, what do you package it with? Mm-hmm. And so we really love, again, to go back to the analogy of fruits. And if fruits work, they have worked for 100 million years. So somehow there's something there. We can have a material that like probably you won't eat most of the time, but the fact that you could eat it makes people understand that nature can eat it too. It's not made from something synthetic that nature has never seen before. It's made from the same building blocks that nature has been using for all that time.
Wow, that was beautiful. You mentioned something about how it maybe doesn't replace every plastic instance, right? Could you talk a little bit about how Notpla and your guys' material compares to things like conventional plastics?
Yeah, so obviously, we appreciate that there's so many different plastics and there's so many different applications. And so we're not here to say seaweed is going to replace plastic, period. It's actually really targeting the places where plastic is the most overkill, doesn't make sense because you have the highest chance of losing it in nature or to kind of like get ingested when in contact with food. And so we realized that seaweed had the right properties to do a really great job at, for example, food service containers. Typically, when you're kind of like getting a meal on the go, it's going to be served in either a full plastic container or like paperboard container that is coated with a thin layer of plastic or needs to rely on PFAS to have the grease and moisture resistance. And that's one of the options where we thought, wow, we can probably replace that thin layer on the inside to hold the grease and moisture of the food for the time that is needed for the performance, and therefore kind of like eliminate that complex mix of board and plastic from the end of life perspective. So that's one of the applications that is a lot more a drop-in replacement. It's a little bit less flashy, but actually that's something that has really scaled up massively over the last kind of like 2-3 years, where we've been able to find something where we can use the same machines, drop in our material as a swap for the synthetics, and actually produce on the same lines with the same jobs and the same people and same factories, a replacement that is free from the plastic and therefore has all of those benefits.
And that's what I actually think is one of the really cool developments as you've evolved, not away from films, but more into this kind of coated paperboard as really that kind of either hero application to get this thing really rolling. How do you approach, and as you're thinking about what's next, how do you develop these new material systems and keep kind of the end of life truly circular?
Yeah, it's a really good question. I think what's really interesting is we need to both kind of like really think through the origin material and the end of life. And by thinking the origin material and essentially like limiting ourselves from using anything that is not already vastly abundant in nature, and stopping ourselves from doing any chemical modification of those natural polymers, we're giving our chance of potentially losing things in nature without ever creating that forever waste. Obviously, it's much better if we manage our waste, but God knows that we are losing a lot of our waste in the wrong places. And so this idea of like only working with things that are already abundant in nature gives us this ability to never create a problem. So our kind of like coated board, it's pretty cool that like it's both recyclable. You can get those fibers back. It works really well with recycling, best grades of kind of like fiber recycling for these types of coatings. You can send it to be composted, and whether it's industrial composting or home composting, because both the cellulose from the board and the coating from seaweed are natural polymers, bacteria and microbes know exactly what to do. But even if it ends up in general waste, which is not the target, or even if it ends up in nature, we've already saved plastic in the first place. And so we're never really kind of like creating a worse outcome. And I think the problem of a lot of synthetic materials is that from an end of life perspective, there's one end of life that works well, recycling or something like this, but all of the other end of life are very problematic. And for us, it's the other round. It's like none of the end of life are problematic. We just make sure that like we are never introducing something that breaks the system.
Kind of like designing for the worst case scenario. It's all of the scenarios, but if it happens the worst case, it's good. It's
and
great
quite a few of our exactly as I said, like quite a few of our partners whether they are stadiums or kind of like coffee shops on campuses or street vendors. They don't always have, from an operational perspective, the composting route or the recycling route enabled from day one. But they aspire to get there. And so we have this future-proof solution to that kind of like journey they are on. They might start with just swapping out the plastic for a better material, preventing all that microplastic from ending up in the food, especially if it's hot food. Is that much more kind of like migration. It's lower carbon compared to alternatives, like up to 79% lower carbon. So you're kind of like having those gains from day one. But the day that they are ready to plug into a composter locally or send to recycling, it is ready for that. And that's a bit how we see this. It's like not waiting for perfection. It's getting started now.
Future-proof. I like that. Seeing Notpla in the hands of so many consumers at stadiums, like you talked about, even here in LA while you're out here, so powerful. Can you tell us a little bit about how transparency and storytelling and visibility has really helped scale Notpla and help, make sustainability more tangible for people?
It's been, from the student kitchen to just a couple of days ago, we passed the milestone 30 million single-use plastics replaced. It feels super exciting to see some of those solutions that often we just talk about at lab scale, prototypes. Here's the one precious sample. No, it's like actually at the scale of like tens of millions and in like 10 countries around the world now, and really starting to be used by some amazing clients like IKEA, like some of the kind of like most renowned stadiums and events. So it feels like it's starting to really have that like critical mass. So that makes me very, very kind of like excited and happy that we are kind of like getting there. It's still a drop in the ocean of what kind of like amount of plastic is used, but it's an industrial scale drop. So it feels like we're kind of like getting there. And I think that the reason why I think being able to bring some of those hero brands on the journey with us is that transparency, is that like we're going to be super kind of like open. We have nothing to hide. We have truth for ourselves because we are kind of like really believing in this. And we're developing those materials with those very kind of like strict guidelines so that you know that you're getting that type of transparency that you can rely on. And in a way, it's a bit thinking like when you got the Notpla logo, that's a bit your seal of approval that like you haven't cut corners. You can rely on someone who's done their due diligence. And obviously, it's easy for us to say it. So many companies have said before, this is plastic free. This is kind of like herbal. For us, what's really special is that like we have gone through the harshest due diligence processes looking at this. Europe is usually quite kind of like strict on those definitions. And so we're the first and currently like still only solution that has been government certified plastic free. The Dutch government kind of like did all of that due diligence, sending samples that they picked up from the market to labs to actually get themselves their own results. It's not self-declaration. It's actually like material scientists who will look at what is on that board and check that it's not chemically modified, that it's a natural polymer. And so that type of certification, it's not something that you can pay $20,000 and get like another seal of approval built by the industry for the industry. It's something that the government says yes or no. And I think that has resonated a lot with some of those brands who are like, that gives me confidence that you guys have done the job. I don't have to have a material scientist in-house, but I think that the Dutch government has done the job. And therefore, it's rebuilding trust that I think has been stretched so much by countless marketing claims and kind of like clever storytelling that means that all of these other brands on the market that were claiming to be plastic free in the Netherlands, they were found to be containing plastic. And that was pretty awkward for them that they had to go and pay the plastic tax. So, yeah.
That's one of the things that I've been most impressed about you and Notpla is that you've stayed true to that story since the beginning, because there are a lot of really great technologies, but often people are blending them with other things to get the qualities that they need to commercialize. So scaling a material innovation company, which is what I would, I guess, call you guys, probably has some unique challenges. The infrastructure of just building a new company, from certification to policy, what barriers have you had to overcome to really bring Notpla to this point? Because I've been impressed at how quickly you've been able to scale it.
how long do we have? No, I mean, like, yes, it's an uphill battle. And at the same time, I think there's a real need that is not met today, which means that even if it's hard and there's lots of obstacles, there are people within those organizations that really want to make this future happen as soon as possible. So it's a story of like obstacles and internal champions who actually navigate internally for you around those obstacles. So it's kind of amazing because it really feels like we've made a lot of progress, not out of our own success or kind of like skills, but just because they were amazing people that like took our hand and be like, okay, well, I'll show you the way. And so I think it's the chicken and egg. Like, how do you convince manufacturers that it's worth putting seaweed on their line? Like, those are pretty expensive machines. It feels like a bit of a risk. Well, you get a brand to actually like show that they really want this, and that makes them that much more motivated. And then you go back to like more brands and say, I can make it at this big factory, and that convinced them. And so there's a lot of that kind of like creating momentum that I think is very hard in most cases, but because behind the scenes, there is this growing concern around the implication of plastics, whether it's on the waste front, on the health front. Everyone knows that we've got to find new solutions. And so that makes it, that primes people to help you to navigate those things. But it's required a lot of funding. It's been 11 years in this journey. So like these things don't happen overnight. And I think it's been a story of, like essentially being stubborn and naive and thinking that we can do it, and people on the other side helping us to get there.
It's been an incredible journey to watch.
Mm-hmm. I'm curious, so EPR is like the hot topic here in the US right now. Everyone's talking about it. It's not just here in the US, but it is what everyone is talking about right now. And EPR is coming after PPWR and a lot of what Europe's already done. And so in their packaging regulations, they're pushing for verified compostability and recyclability. Now, how does that, the verification and regulations policy, how does it all frame and shape the innovation roadmap at Notpla?
I think it's been really interesting. And obviously there's like so many, the problem is complex and we shouldn't kind of like shy away from the nuances. But I think that essentially like there's a lot of incumbent interest in keeping quite a lot of plastic in circulation. So I think most of the traction we've seen has benefited the recycling industry, which is plastic recycling, and like reuse, which is definitely like one of the great solutions we have to unlock, but often it's plastic reuse. And so I think there's been a relatively kind of like narrow or almost kind of like invisible set of other solutions that today haven't really been brought to the surface in most EPR bills. But it's starting to change because we are, again, like showing new solutions at scale. And so this idea of unmodified natural polymers is starting to catch a lot of attention, starting with like the Single-Use Plastic Directive and the PPWR that like define quite clearly that framework. And then Californian kind of like SP54 is using a very similar definition. So it's starting to get momentum. And essentially what we want is to show that there is a solution that doesn't rely on plastic, which could be eco-modulated to incite more and more people to consider that as like one of the ways to eliminate more plastic from the system. And it's starting to really kind of like get traction. So with a few other innovators, we actually created the Natural Polymers Group to kind of like show that there is a growing industry that is like aligning with those very strict guideline principles, so that it's not just going to be seaweed, there's going to be some mushroom, there's going to be some shrimp shells, there's going to be lots of like exciting materials that are going to be available. And those should also be seen as a strategy to reduce the amount of plastic that ends up in nature, which usually is one of the primary objectives of those EPR systems. And so we're starting to get mentions, we're starting to get kind of like recognition. And I think that's the first step to say, hey, yes, we can do a lot on like plastic recycling, been doing for like 50 years, but anyway, and we can like start to implement more of those kind of like models. But we can also be very kind of like purist in those material categories that mean we are not taking that risk. And I think that's going to help like slightly slice into the compostable category, which really today stands for nothing and everything at the same time. And I think the problem of the first generation of compostables is that they're quite hard to compost. They require very kind of like specific requirements. They don't break down in nature. They just fragment into microplastics in nature. PLA, those materials are synthetic. They might not be made from oil, which is already a great starting point, but they are non-existent in nature. And I think we're trying to redefine a little bit the understanding of what compostable can mean when we're using those natural polymers, because they've been around for hundreds of millions of years. They break down at the speed of the peel of a fruit. So they are much more compatible with all of the infrastructure that we need to build around the food waste that is not going anywhere, we're going to continue to have. And hopefully that makes people realize that there is more nuance in this, and we can really create some nice supportive feedback loop for those better materials and eco-modulate all of this so that eventually the incentive goes towards the solutions that like remove plastic equation.
So let me shift gears a little bit. At the design lab, we're always looking for what's new. So we're finding these material innovators, but there's often tension between material innovation and manufacturing reality or practicality. And so how do you work with converters or brand owners to ensure that the Notpla materials really can integrate smoothly into existing packaging systems?
That's the game. So I think that like we've matured a lot, and obviously like we're still a small organization, but we have a pretty decent sized R&D kind of like team and capabilities for the overall size that we are. And so I think we've really invested in lab and like machine capabilities to be able to prove at a pilot scale a lot of the parameters and de-risk that kind of like scale up, which usually is the point where most big manufacturers struggle to engage with the new material categories. How is it going to work on my machine? Am I taking a risk? Is it all going to kind of like go up in flames? I don't know what. So by really showing them with like industry standard processes at like that pilot scale in our lab, 10,000 square feet of kind of like labs and machine halls in East London, we've been able to convince quite a few to be on the journey with us. And I think it's a bit of a self-fulfilling prophecy. Once you've got a manufacturer that can produce 30 million units at industry standard speed and so on, the next one is that much easier to convince, and so on and so forth. So it's been really exciting to see that we are kind of like shortening the time of convincing more and more as we're progressing. And now that we're entering injection molding and like film extrusion and other processes that are not yet at a validation level that we have had on our coating, we're able to use those as examples and like data points that make those big guys want to be part of the journey with us and get excited, rather than be like risk adverse and not want to take that kind of like chance of breaking the machine down.
And so I think a lot of those decisions come down to data as well. It's in practicality in the lab, but then also the data that backs it up. How do you see things like material intelligence, examples like LCA data and certifications and transparency? How does it all play in accelerating the trust that you were talking about and adoption of these natural polymers?
I think it's critical. I think like if you can show from the science principles that all of this stacks up, it's not just a marketing story, you get everyone across the board kind of like with it. If you're just kind of like going on the story, you just get the believers, but then you've got all of the people who actually know the industry, due diligence they'll find the crux. So you have to kind of like be able to be super kind of like plugged in with the requirements and the kind of like general asks from the industry and answer heads on all of those things. And so we've invested a lot in not only just getting the data, but getting the data from trusted sources. Our LCA was kind of like independently verified by one of the like leading European player in that space, so that a big contractor is actually going to see this as like the same quality of data that they used to see, not just some kind of like new self-declared kind of like data points. And I think that there's a lot more that we can do. Like one thing that I'm actually quite excited about is when you look at coatings, there's actually no certification for any of the material coatings on the market. Plastic doesn't have certification. Like the minerals that are often kind of like on board, they don't have certificate. But seaweed, there's an amazing opportunity to think of a FSC or PEFC kind of like style certification of the incredible sustainability credentials of that biomass compared to where your plastic might come from. There's no traceability. It's very kind of like opaque. And I think by creating above and beyond certification, we can actually make the industry get excited about this, because it's giving them an even bigger reason to switch, because they can transact on that value all the way to the consumer. So we're taking the first steps into this idea of creating a kind of like FSC style certification for seaweed that like makes us kind of like float way above plastics or kind of like mineral coatings.
That's really exciting. When you look ahead, where do you see the biggest opportunities for regenerative materials or natural polymers like seaweed, not just as a substitute for plastic, but really as a catalyst for rethinking packaging entirely?
I think like I'm really excited about like continuing this dual track drop-in replacements that can eliminate lots of plastic from some of those use cases where plastic is the most overkill material. And at the same time, continuing to like challenge a bit the status quo. This is my test. I've got my props, but you might have seen our like olive oil pipettes. That's a completely new form factor. Like that's something that people can get excited about. That would be very hard to make out of plastic, but we can create something that is completely different out of seaweed. And so our innovation team is also kind of like keeping in mind that like those new materials don't have to just be a copy paste of plastic or match the specs of plastic. They can create their own capabilities. Our films for kind of like little sachets and bags, we can make them edible, soluble. So there's all sorts of like cool applications that would be impossible to do with plastic that all of a sudden you can create to get more people to think more positively about the future of packaging. And I think that's something that like we should continue to do, continuing to take inspiration from nature, because we are still very far from nature. I mean, like literally, like you take a fruit, you throw it away, you get a tree, and then it's going to produce 100 fruits. Like, when are we getting packaging that can do that? Like, there's still so much that we can imagine is going to come out of this biomimicry approach. So that's the thing that like excites me about using this new natural block of material, natural polymers. We can do things that we couldn't do with the previous ones.
I'm sorry. I have another question that's a hot topic on everybody's mind today, and that's AI. How are you guys using AI, and is it part of your R&D and development process? Isn't it helping you accelerate the technologies faster?
It's a good question. It's like obviously like on everyone's mind. I think I'm usually like the one excited about the new opportunities. So we've definitely been very curious about what's coming up. I think there's lots of people who are starting to look at how it could accelerate material development cycles, how it could kind of like help you to kind of like cut down the number of experiments that you could run and so on, all the way to kind of like replacing your scientists altogether. I think like we are nowhere near that. Everything we've tried makes us believe that like we're doubling down on our teams and humans. I think there's a little bit of augmentation of kind of like combining people with the access to kind of like the whole of like academia at your fingertips that is quite powerful. But at the end of the day, I think the challenges with materials is that there's lots of things that we still don't know. And I think AI is really good at like filtering things out of very detailed data sets of everything you know, but it's not really good at like the unknown. And so it's still sometimes we test new material and things will change when we feel that we're putting the same inputs in, but there might be like natural variations from kind of like the temperature of the ocean or kind of like the strength of the waves. All of these things have an impact, but it's not measured. It's impossible to measure. And so I think that like AI is not really solving for that because it needs all of that kind of like input data. So I think that I'm seeing a bit the limits of AI for some time to kind of like replace any real kind of like human input from our scientists. But like things change fast. I think we're keeping our eyes on, we try to collect data because I think data will be valuable in the future. So we've kind of like put sensors on our kind of like equipment to have that like data log. But right now, I haven't seen something that convinced me that like the future is AI for materials.
That's really interesting. Before I get to the question that we ask all of our guests, I have actually a fun question. Now, I have people come to us at the lab and say, hey, have you heard about this material, this product, this company, this innovation, this patent, all these really cool stuff. And that's one of my favorite parts of my job. I have gotten, have you heard of Notpla, not PLA? I have heard so many pronunciations of Notpla. I'm curious, what's the weirdest way that someone has pronounced your company back to you?
That's a good question. And it's definitely something we are fully embracing. There is no, well, we say Notpla for ourselves, but I actually like whenever we are at like a conference or some place where there's going to be some people that are quite knowledgeable about packaging and materials and others that are complete general public. I love that it's almost kind of like filtering out who's from which category, because if they say not PLA, you know that you can like get a little bit deeper on the complexity and the details. If they say not PLA, you assume that they know nothing about like the material category and you're taking it more general. So it's almost kind of like a way of testing who you're talking to. But certainly we quite like the duality of being very clearly not PLA, because I think that like the incumbent in our space has been PLA for the last kind of like decade. So yeah, it works both ways. We've kind of like one which is fun is like our first product, OHO, those like little bubbles. It's like OOHO exclamation mark. We came up with it in the kitchen, so it was like early days. We didn't think this through too much, but like the name came from like the reaction of surprise and curiosity that comes when you see one of these things, like, oh. And so that one is really cool because like wherever we go in the world, people have a different sound for like reaction. So yeah, in Japan it's like ooh, or like, so I love how like that keeps on happening. We go on like a stand in another country and someone sees it like ooh, and I'm like, yes, that's the sound that we wanted to capture in the name. So it's all about embracing everyone's curiosity.
I love that. We have a few products that Chris has named that are we get different pronunciations of everything, and I think it adds to the story for sure. It's a great opener. So I wanted to end. Thank you so much for being on this podcast. I wanted to end with one final question. We talked a little bit about the future of packaging, the future of AI, the future of materials and of innovation. When you think about the future of packaging, what is something that gives you a lot of hope?
I think this natural polymers group, for me, that's super exciting because I feel like we're at the beginning of a new industry. And like, if you think like we've been making paper for a few millennia or something like this, but there was a first point. There was a moment where we unlocked kind of like metals or glass and it feels like with natural polymers, we're a bit at this moment where we are opening our eyes about the fact that this is a valuable subset of the material kind of like map that goes into packaging and other kind of like categories. And so it feels like we're finding each other with other innovators, and we are like literally just like 7 numbers now. But like, I think that like in 2-3 years time, we could be like 50, 100, 200 companies that follow those kind of like principles of using the building blocks that nature has already tried and tested for hundreds of millions of years. And so I'm super excited about us tapping more into nature, and like nature's materials should be the main materials in circulation. Like we still can do some really cool stuff with synthetic materials, but I think that those we have to be careful about where they end up and which use case. And I think there's lots, if not every case, but like many cases where nature has cracked it somewhere. It's just that we have been a little bit lazy. We could do whatever we dreamt of with like petrochemicals, and we could get easily kind of like whatever properties we wanted. Let's be a little bit lazy and look at nature for the answer and spend the effort and time to actually kind of like understand how we can leverage that for the particular applications. And then I think we're going to have a super exciting set of materials. So yeah, I can't wait to see how many natural polymers we can see at scale next year.
Yeah, me too.
It's an exciting area, something we'll definitely be tracking. So, thanks for the amazing work that you and your team are doing.
Thank you very much.
I'm so glad that we caught Pierre when he was in town.
It was awesome. He is such an inspiring leader in this space.
Yeah, I think it was a great conversation. Every time we talk to him, I learn something new. I have new questions for him every time. It feels like too. So I think one of the big things that I took away from it was how they have been using storytelling pretty much from their inception, really as a vehicle to propel their mission forward through their shot prize and some of the things, their projects that they're working on with Wimbledon and some other stadiums as well.
And one of the big things that I took as a takeaway is really this whole idea of natural polymers, this natural polymers group that they're part of. They're really trying to push this new type of materials that have not been manipulated or blended with anything else, but they are pure. And if we can get packaging that meets that requirement, I mean, we know that it can't turn into waste. It's inherently circular in the way that it's designed. It really is the holy grail. And I think Notpla is one of the companies that's probably the closest to achieving that in a lot of the conversations that we've had.
Yeah, I'm really excited for their future. I'm excited to see what's next. I'm excited to see what we could do together. It was a great conversation, and I'm excited for what's next.
All right. Well, if you enjoyed this episode, please give us a 5-star review, share it with a colleague, and tune in next time as we continue to find the next big innovator that's going to drive and change the future of packaging.